Hi students, I am Dr. Reena Gupta and in this lecture we are going to discuss the solid state part 2. Okay. In the first part we have discussed the amorphous solids and crystalline solids. Because in our syllabus there is only crystalline solids, so let's recapitulate some characteristics of the crystalline solids. First of all, these are long range order solids, means they have the regular pattern of the arrangement, okay, and they form the three-dimensional network of the solids. Fine. Next is they are anisotropic in nature, means they have the different values of the physical properties in the different directions. Third is they have sharp melting point, and fourth, whenever they will cut they always give the smooth surfaces. So these are the some characteristics. Next is the classification of crystalline solids. So there are number of the bases that we can classify them, but here we are classifying the crystalline solids on the basis of nature of the constituent particles and the nature of the binding forces or the forces of attraction which bind these constituent particles. And on this basis we can divide the crystalline solids into four types. These are the covalent solids, metallic solids, ionic solids, and the molecular solids. Okay, so let's see what are the constituent particles present in these solids. So in case of the covalent solid, the constituent particle is a non-metal atom, any non-metal atom. Okay, they may be same or they may be different. And in case of the metals, of course, metallic solids have the metal atom, but in actually in case of metal atom अगर हम देखें तो exactly not the metal atom, it is actually the kernel in the sea of electrons are present as a constituent. Means we know what are the metal which have tendency to lose the electron. तो suppose एक atom है, it loses the electron, and after losing the electron, this is called outermost electron, this is called the core electron. Okay, and this portion is called the kernel. This positive species is known as the kernel. Okay, so there these atoms are arranged, kernels are arranged in a regular pattern, and the electrons are present outside these kernels. Okay, so here it looks like that these kernels, they have the fixed position and electrons are free to move. Looks like that kernels are present in the sea of electron. So this is actually metal atom is a constituent particle, but in actually should be written as the kernels in the sea of electrons. Fine. And in case of the ionic solids, obviously ions are the constituent particles, and these ions are both cations as well as anions. And from the name molecular solids, of course the constituent particles are molecules. Okay, now binding forces. In case of the covalent solids, why they are called covalent solids? Because in the constituent particles covalent bonds are present. So what are the binding forces? The covalent bond is a binding force. Okay, and in the case of metallic solids, obviously the metallic bond is called the binding force. So what is the metallic bond? It is a force of attraction present between this core electron and kernel. Okay, so this is called metallic bond. And remember, the individual metallic bond is very weak, but the ओवरऑल अगर हम इस मेटालिक फोर्सेस को समराइज करें या सम अप करें तो टोटल स्ट्रेंथ ऑफ दीज मेटालिक फोर्सेस इज वेरी हाई. As a result, the metals always have high tensile strength, and because of the presence of these free electrons, they are good conductor of electricity, even in the solid state, good conductor of heat, sonority, malleability, ductility, and all these properties, physical properties which the metal shows, that is only because of the free electrons present in the metallic solids. Fine. And in case of the ionic solids, of course यहाँ ionic bond ही present है between दो ions के बीच में जो भी bond होगा, that is the ionic bond. And this ionic bond is also can be termed as the electrostatic bond, because electrostatic forces are present in between the two ions, positive and negative. And in case of the molecules, the van der Waals forces are present between these two molecules. Suppose अगर मैं यहाँ बात कर लेती हूँ कार्बन डाइऑक्साइड एंड कार्बन डाइऑक्साइड, तो this molecule and in this molecule, okay, these two are termed as molecules because they have independent existence. तो इस कार्बन डाइऑक्साइड molecule के अपने independent existence है, this has its own independent existence. और इस कार्बन डाइऑक्साइड गैस को अगर आप सॉलिड स्टेट में लेके आते हैं, मीन्स व्हेन दे कम इन द सॉलिड स्टेट, ऑफ कोर्स दे विल कम क्लोज टू ईच अदर. ठीक है, एंड वेन एवर दे विल कम क्लोज टू ईच अदर, सम फोर्सेस विल डेवलप बिटवीन देम, एंड दीज फोर्सेस आर ऑब्वियसली द van der Waals forces. Fine. And other than van der Waals forces, there may be the hydrogen bonding also present between the molecular solids. Fine. Now next come to the covalent solids. अगर हम covalent solids की बात करते हैं, तो covalent solids they may have the same atom और the different atom. Same atom, for example, मैं कार्बन की बात कर रही हूँ, तो कार्बन के अगर हम सॉलिड्स की बात करें, क्रिस्टलाइन सॉलिड्स की बात करें, तो दो तरह के हमें क्रिस्टलाइन सॉलिड्स देता है कार्बन, तीन तरह के ऑब्वियसली, विच आर द एलोट्रॉप्स, क्रिस्टलाइन फॉर्म ऑफ द कार्बन, दैट इज graphite, okay, sorry, diamond. Then this is the graphite which is present in the pencil leads, okay, and third is the fullerenes. Fine. These are the covalent solids. Amorphous forms are of course the coal, charcoal, etc. These are the amorphous forms of the carbon. Okay, these are also covalent solids, but they are the amorphous solids because they don't have the regular or long range order. Okay, and these covalent solids may have the different atoms like silicon, carbide. So दो atom different है, silicon and carbon, and these arranged in a three-dimensional network. So this is the unit cell of the silicon carbide, where the large size atom is of silicon and the small size atom that is of carbon, and they are arranged in a very regular pattern. That's why they form the crystalline solids. Okay, और अगर हम इसको normal routine में देखें तो it looks like this. Fine. Now next is a metallic solids. तो all the metals, कहीं भी आप metallic solid की बात करते हो तो you must know कि that must be consist the metal atom like iron, gold, platinum, sodium, magnesium, calcium. You may name any metal because 80% metals are present in the periodic table. Okay, in the nature 80% metals मिलते हैं हमें. Okay, and all these are arranged in a three-dimensional network, and this is called the unit cell. Fine, unit cell, and unit cell is nothing. This is the smallest arrangement of the atoms or the particles which is repeated again and again. This will be discussed in the next lecture only. Okay, here this unit cell is of BCC type because atoms are present at the corners as well as exactly in the center or body of the this unit cell. Fine. And in case of the ionic solids, they are also called salts. Fine. And number of the examples like sodium chloride, zinc sulfide, calcium sulfate, potassium chloride. You may name any ionic solid, and in all ionic solids they are again arranged in the three-dimensional network, just like metallic solids, just like the covalent solids. Fine. Next is the molecular solids. First type of the molecular solid is the polar solid. Polar means कि suppose मैं यहाँ solid सल्फर डाइऑक्साइड की जगह एग्जाम्पल ले रही हूँ, that is HCl. ठीक है. तो you know very well here the hydrogen has the partial positive charge and the chlorine has partial negative charge, and where you can show the charges on the molecule, so that molecule is polar in nature, because you can show the two poles, you can show the charge separation. तो जहाँ भी आप चार्ज सेपरेशन दिखा सकते हैं तो जनरली दैट इज, दिस इज नॉट द हार्ड एंड फास्ट, बिकॉज अगर हमारे इसमें चार्ज सेपरेशन है लेकिन अगर सिमेट्रिकल है तो वो नॉन पोलर हो जाएंगे. बट हेयर वी कैन शो द चार्ज सेपरेशन, सो इट मीन्स दिस इज पोलर. और अगर आप इसी HCl को, गैस को क्या ले लें हम, दैट इज इन द सॉलिड स्टेट. ओके, तो यहाँ इन दोनों के बीच में जो फोर्सेस अराइज होंगी दैट इज द डाइपोल, क्योंकि ये भी एक डाइपोल बना हुआ है एंड दिस इज ऑल्सो अ डाइपोल, सो हियर देयर विल बी डाइपोल डाइपोल इंट्रैक्शन. तो इन पोलर मॉलिक्यूलर सॉलिड्स कौन सी फोर्सेस रहती हैं, कौन सी वंडरवल फोर्सेस हैं, 5 टाइप्स ऑफ वंडर फोर्सेस हैं. कौन सी वंडरवल फोर्सेस हैं, दैट इज डाइपोल डाइपोल इंट्रैक्शंस. ठीक है. एंड सिमिलरली दिस सल्फर डाइऑक्साइड इज ऑल्सो पोलर. और अगर आप सल्फर डाइऑक्साइड गैस को सॉलिड स्टेट में लाएं तो इट लुक्स लाइक समथिंग लाइक दिस. ठीक है. सो दिस इज अ सॉलिड फॉर्म ऑफ द सल्फर, solid form of the sulfur dioxide. Fine. And this is a polar molecular solid. Second is the non-polar molecular solid. For example, हमने बात करी कार्बन डाइऑक्साइड की. ठीक है. ऑफकोर्स यहाँ भी आप चार्ज सेपरेशन दिखा सकते हो, दैट इज डेल्टा नेगेटिव ऑन ऑक्सीजन एंड डेल्टा पॉजिटिव ऑन द कार्बन. बट हेयर दिस मॉलिक्यूल इज सिमेट्रिकल, सो दिस इज नॉन पोलर, एंड इट इन बिटवीन द नॉन पोलर molecular solids, London forces, this is the again type of the van der Waals forces. So London forces are present between these non-polar molecular solids. And dry ice, यानी कि कार्बन डाइऑक्साइड in the solid form, it looks like this. Okay, ये जनरली हमें it also पैक फॉर्म में भी मिलती है. You can also purchase it. Now the third form, जहाँ हमारे पास molecular solid है, van der Waals forces के साथ साथ और क्या प्रेजेंट है, हाइड्रोजन बॉन्डिंग. Such molecular solids are known as hydrogen bonded molecular solids, and we know how the ice looks like. And this is hydrogen bonded क्यों, because here in this case this is the water molecule, this is the another water molecule. So इस water molecule और इस water molecule में in between these two water molecules van der Waals forces are present, that is dipole dipole, plus also hydrogen bonding is present. Okay, so that's why these molecular solids are called the hydrogen bonded molecular solids. Fine. So molecular solids are of 3 types: polar, non-polar and hydrogen bonded molecular solids. Fine. So this is all about the classification of the crystalline solids. वेरी सिंपल फॉर्म में मैंने इसको देने की कोशिश की है. आई होप आपको क्लियर हो गया होगा. सो लेट्स प्रैक्टिस सम क्वेश्चंस. Okay, so our first question is the polar molecular solids are held together by. मैंने अभी बोला कि जहाँ पे पोलैरिटी होगी, मीन जैसे मैंने अभी HCl का आपको एग्जांपल दिया था. ठीक है. इन HCl मॉलिक्यूल्स डेल्टा नेगेटिव, डेल्टा पॉजिटिव, डेल्टा नेगेटिव, पॉजिटिव एंड डेल्टा नेगेटिव. सो दिस इज अ पोलर मॉलिक्यूल फर्स्ट ऑफ ऑल. ठीक है. और बिकॉज अगर ये पोलर है तो दिस इज कॉल्ड अ डाइपोल. 2 पोल हैं, that is one positive and one negative. Here is again it's a dipole, and between these two dipole the forces of attraction are present. किसके बीच में, डेल्टा पॉजिटिव एंड delta negative and delta positive के बीच में. So these interactions are called dipole interactions, and these are the one of the type of van der Waals forces. So here the answer is dipole interactions. Okay, next question is, second question is, आइस हैज 3-dimensional lattice structure, crystal structure. तो ये है हमारे पास आइस. Here this oxygen from the 2 bonds with the 2 hydrogens. ठीक है, and again this is the another molecule, again another molecule. Okay, and this oxygen also form the hydrogen bonding. ठीक है, and this result of this hydrogen bonding, what happens, the number of the vacant spaces are present, and generally ये सिर्फ remember करना है, that is 1/2 the total volume is unoccupied. Okay, यानी कि 50% क्या है यहाँ पे, these vacant spaces are present. Fine. Now next question is, that is zinc sulfide. Of course zinc क्या है, metal. ठीक है, एंड सल्फाइड क्या है, दैट इज नॉन मेटल. ऑब्वियसली दीज आर द आयंस, एंड बिटवीन द आयंस ionic bond is present, so it's a ionic crystal. Now next is, which solids are the giant solids or network solids, that is the covalent solids. Covalent solids have the huge network. ओके, सो सभी के पास होते हैं ऑब्वियसली मॉलिक्यूलर, आयनिक, मेटालिक, बट द giant solids are that is present in the only covalent solids. Okay, now next is, in graphite carbon atoms are interlinked. तो ये हमारे पास मेंबर्स हैं. ठीक है, तो दिस इज द स्ट्रक्चर ऑफ द ग्रेफाइट. यू नो वेरी वेल, 9th स्टैंडर्ड में भी किया होगा, इवन 10th स्टैंडर्ड में भी. ठीक है, हेयर दिस कार्बन एटम दैट इज इंटरलिंक मेंबर्स कितनी है हमारे पास, इंटरलिंक्ड मेंबर्ड रिंग्स. ठीक है, तो अगर मैं एक इसकी बात कर लूँ, बिल्कुल सेंटर में आप चेक कर लीजिए. ठीक, तो दिस इज द सेंटर वन. Okay, here it is linked to how many membered rings, 1 2 3 4 5 6. So answer is 6. Okay, now which shows the anisotropic solids are crystalline solids. Okay, so here glass, wood and paper, these all are amorphous solids, so all they will show the isotropic. Now next is, which of the following is hydrogen bonded. याद रखिएगा कि हाइड्रोजन बॉन्ड जो है, हाइड्रोजन कैन फॉर्म द हाइड्रोजन बॉन्डिंग विद फ्लोरीन, ऑक्सीजन एंड नाइट्रोजन ओनली. ओके, सो रिमेंबर करने, याद रखने का एक सिंपल सा फंडा है, दैट हाइड्रोजन कैन फॉर्म द बॉन्ड विद फोन, दैट इज फ्लोरीन, ऑक्सीजन एंड नाइट्रोजन. सो हेयर ओनली इन द केस ऑफ hydrogen and oxygen are present, so hydrogen bonded molecular crystal is this one only. Next is the crystals which are good conductor of electricity as well as heat. Ionic solids की बात करें तो they are good conductor of the electricity but in the molten state, but they are not good conductor of the heat. Covalent solids, obviously these are not good conductor of heat or electricity both, because they don't have the free electrons, so answer is only metallic solids, because they have the free electrons. As a result, it becomes good conductor of heat and electricity. Now next is the example of the metallic solid. Just find out which one is the metal. Carbon is non-metal, silicon is non-metal. Here this is the consist ions, means it's a ionic solid. So tungsten, this is a metal, that's why it is a metallic solid. Fine. नेक्स्ट इज 10th क्वेश्चन है हमारा, विच अमंग द फॉलोइंग शो एनआइसोट्रॉपी। अगेन सेम क्वेश्चन आ गया, ग्लास, वुड एंड पेपर, दे ऑल आर व्हाट, amorphous solids. Only barium chloride is the ionic solid. Fine. Next is, which of the following statement is true? Just check it. Take your time, or the 2 to 3 seconds. Read out the statements. Okay. And here answer is D. The crystalline solids are anisotropic while amorphous are isotropic. Fine. So this is all about the crystalline solids and their classification. Thank you.